How to explain why the earth shakes during an earthquake.
Wallace, don't slam the door like that. You made us jump. I thought it was an earthquake.
What's an earthquake?
You don't know what an earthquake is?
Yes, but what really happens during an earthquake?
I know that during an earthquake, the ground suddenly shakes really hard.
Hey, I know that during an earthquake, all the objects in the house shake, and they even sometimes fall and break.
Do you know that not only the objects shake during an earthquake, the walls in the house and big buildings shake as well?
Wow, it is terrible! What I would really like to know now is what actually happens when there is an earthquake.
Yes, Madeline, tell us, why does the ground shake?
That's a good question, children. You already know that an earthquake is when the ground shakes hard. The fact is that the earth is covered in huge plates which move and rub against one another all the time and cause thousands of small quakes that we can't always feel.
What do you mean, big plates? The earth is not made of one big piece.
No, in fact it isn't, Wallace. Look at the whole globe. To be able to see it more clearly, let's remove the oceans. Can you now see that the earth is divided into big plates? These rocky plates fit into each other like a big jigsaw puzzle. These lay on the earth's mantle and rub against each other all the time. They carry the oceans and the continents. Look here, for example. You see the Eurasian plate? That's where you can find Switzerland, France, Italy, Norway, China, Russia, United Kingdom and many others. Look at it more closely. These large plates are surrounded by huge faults, which we call rifts. When one plate suddenly slides away from the others along these rifts, this is what causes an earthquake. In some places, the plates move away from each other. This is where an ocean is formed. There are also places where two plates collide with each other. This is when a chain of mountains is formed. Sometimes the plates collide and one slides under the other. This is when volcanoes are formed.
How is that possible, Manon?
I have an idea, Wallace. In order to make you understand properly, let's go and explore the centre of the earth. You'll see we'll use the super-fast lift that drops us right to the centre of the earth. Wallace, you're now our super explorer. I'll be able to guide you from the operating room. Let's go, children, come with me. We're off! Here we are. Wallace has just reached down to the centre of the earth. 6,400 kilometres underground. Wallace, can you hear us?
Yes, I can. Wow, it's really hot here. My thermometer tells me that it's 6,000 degrees here. The rock is hard. My spectrometer tells me that it is mainly iron.
Children, here, Wallace is in the heart of the core of the earth. It's like a battery to the earth because it generates so much energy that it heats the core which surrounds it.
Manon, I've gone up a bit. I'm now 5,000 kilometres deep and the temperature has decreased slightly, but the sensors still indicate that it is still 5,000 degrees. I can see that the rocks are still mainly made of iron, but they are liquid.
Wallace, you're now in the core of the earth, and you're right. The core is indeed liquid. Keep coming back up.
Manon, I am now 2,900 kilometres deep.
Wallace has just entered the mantle of the earth. Look carefully, children. Temperature has come down drastically. It's now 3,000, 2,000 degrees. Wait, Wallace, you're already only at 700 kilometres deep. You're coming back up too fast.
The rock is changing a lot in the mantle. It changes shapes like Play-Doh. Wow, my spectrometer tells me it is made of iron, silicate and magnesium. Wait, here I can see a law of rock. It is almost liquid. It is emerging to the surface. I'm going to try to follow it.
OK, off you go, Wallace. Children, remember that we saw the big plates on the surface of the Earth moving around and pushing each other? Thanks to Wallace, you'll now understand what we call the tectonic plates. Just like hot water in a saucepan, some of the rocks which melted because of the extremely high temperatures towards the centre of the Earth come up slowly towards the surface. They form the marine volcanoes. The magma which rises cools down as soon as it's in contact with the cold ocean waters, continuously forming oceanic plates.
Hang on, here I record a lot of quakes.
Well done, Wallace. Let's carry on, children. These oceanic plates slowly move up towards the surface of the globe until they collide with another plate and then dive into the mantle of the Earth. Very slowly they warm up and become as soft as Play-Doh again. Here you are. You now understand what makes the big plates move around on the surface of the Earth. Wallace, could you go inside the plates to see what happens to them when they collide, please?
It is just amazing, Madam. I am here 10 kilometres deep, and the rock has solidified again. It is hard, but...
Look, children. At that level, the rock is so hard and cold that it can even break.
Wow, wow, wow! The noise here is amazing! Everything is shaking, and the rock is breaking down. Wow! Mama, it is a quake! I am recording it!
OK, Wallace. Do bring back all the recordings. So, children, let's try and understand what's just happened. Look at this piece of wood in my hand. With force, I can change its shape. First, it bends, and if I increase the strength, it snaps, making a noise and creating energy.
Phew! I am back, Madam. That was very scary.
That was very helpful, Wallace. Well done. Now, follow me, children. I'll show you what happens when there is an earthquake. When the rocks underground are breaking, they create energy, just like that piece of wood did. This energy spreads towards the surface in the form of seismic waves, which makes the ground shake. This is why the houses and schools also shake. To measure this energy created by the quake, we use a seismometer, which is on the ground and records all the vibration of the Earth. It's thanks to these measurements that scientists can calculate the magnitude of the earthquake. Remember, the higher the magnitude, the greater the energy created by the quake. For example, in Valais, the greatest quake ever recorded had a magnitude of 6 and took place in 1946 near Sierre. To this day, the greatest quake ever recorded had a magnitude of 9.5, and it was in Chile in South America. Now that we understand why there are earthquakes on Earth and their impacts on the surroundings, we have to learn how to protect ourselves from these quakes. But that's another adventure.